And I'm Logan Hubbard.
Today we're going to show you a concept of electromagnetism. We're going to explain to you what Ampere's law is and how it works in the real world. So real basic, Ampere's law says that a magnetic field is strengthened by the amount of current pushed through a particular area. Current is basically just the movement of electricity. You can think of it as when you plug in your iPod, or you plug in a television or microwave. That is electricity, that is current moving through the wire to power that device. Also, a magnetic field is basically like a magnet where you can't see it. The Earth has a magnetic field. Magnetic fields are used on roller coasters for brakes and are also used in television. So Mike is going to show you the materials for experiment, and then Logan's going to actually take you through that experiment. So, Mike?
Okay, thanks Nate. To build an electromagnet, you'll need a few basic materials. As a power source, we're using two 6-volt batteries that can be bought almost anywhere. The wire that we're using is a copper wire, and that's what the current is going to flow through, or the electricity like Nate was explaining. Then we have a few extra tools to help us visualize and amplify the magnetic field so that you can actually see what's going on. This is an iron rod, and this is going to be going through a wire, which Logan is going to show you. And this helps the magnetic field be more profound so that you can actually see what's going on in this experiment. Just two quick tools that we're going to use. This is a compass. Right now it's pointing in the direction of the Earth's magnetic field, which is in this direction. We're also going to pick up a few paper clips to show you how strong the magnetic field actually is. Now that we have all the materials laid out, Logan's going to show you how to actually set up the experiment. And so, Logan, take it away.
Today we're going to be building an electromagnet. So what you're going to need is a coil of wire, and like we said with Ampere's law, that when you run electricity through a wire, you automatically create a magnetic field. So to make that magnetic field, we're going to create something called a solenoid. So basically, a solenoid is just a coil of that wire. So you're coiling that magnetic field and making it a lot stronger. So what you do is you take a wire and you take some wire cutters, and you need to strip the ends off the wires so that the actual metal is exposed. This is copper wire. Once you strip those down, you want to leave a little bit of slack on the ends, and then you want to start taking the wire, and this might be a two-person task. You want to take the wire, and you want to coil it tightly around. So depending on the type of wire, some of it might be a little more springy, some of it might stick in place, but it might be a good idea to get some tape and just run tape around this as you're doing it so it doesn't unwrap. But for the interest of time, so once you finish this, the end result, we went ahead and made one, is something that looks like this. Again, we're wrapping around that the iron rod to increase the strength of the magnetic field, and then we have the wires that the current is going to run through. So, moving on to the actual experiment, these are the two batteries, and we're going to hook these two batteries up in something called series, which will increase the amount of electricity flowing out of them. So what you do for that, these are labeled, there's negative and positive, and then negative and positive. You want to connect the positive terminal on one battery to the negative terminal on another battery. Alright? And now, you want to take this electromagnet, and you want to attach it to the positive terminal on this battery, and then we want to take this piece and touch it to the negative side. Now, just to let you know, a safety factor is if you leave this hooked up for a long period of time, it'll get hot. So you don't want to do that. Just use it for the experiment to see what it does to a compass. So right now we have this compass pointing north, right? So when I hook this up to this terminal and I run the compass near the end of this wire, I end up getting a magnetic field coming out of the end of this copper rod. And the interesting thing about this is because of this solenoid, we actually ended up making a magnet. So we have a north and a south pole coming out of this thing. So the magnetic field, just so you know, north points to south and vice versa. And so to figure out which end of this rod is the south pole, we just have to see which side north goes to. So this end is the south pole, and this end is the north pole. So yeah, this magnetic field can be pretty strong too, because you can pick up things, anything that can be magnetic, you can pick it up using a magnetic field, and even paper clips. So pretty cool, right? But there are many applications in the real world along with this, though. So maybe if you wanted to take that away.
Yeah, magnetic fields are used all over the place. They're prominent in televisions, use them a lot of times in microwaves. One of the really cool applications that has been pretty recently implemented is on roller coasters. The roller coaster, the Dragster in Cedar Point, uses a magnetic field in order to brake the carts, so to stop them, to prevent them from keep going around the track. If we didn't have, you know, this knowledge about magnetic fields and the current and how they work, though that car will just keep going, and it would take a very long straightaway in order to brake it. So magnetic fields are very useful and a very awesome thing in order to understand. Just remember a few safety tips. Make sure you have a parent with you while you conduct this experiment. Always take safety precautions and be careful, but most of all, have fun, because physics is pretty awesome.
Okay, thanks for being with us today,
Thanks.
and hope you have some fun trying this at home.
Yep. See ya.